In this video, I'm going to talk about a three-phase system or three-phase circuit. So the first question is, what is phase? Phase is nothing but a winding or a coil in a generator. So basically, if you look at a three-phase generator, we'll end up having three coils. So that's a phase A, phase B, phase C, three coils. Okay, so the phases usually represent either ABC or YB or 1 2 3. RYB indicates red, yellow and blue. So here I didn't follow the rules exactly. R indicates red, Y indicates yellow, B indicates blue. Okay, I used black instead of yellow here. Okay, now whenever I asked what is the phase in the class, everyone talks about phase difference. Okay, the phase difference is nothing but if you have two waveforms. Okay, so this is A, it could be a current or voltage. Another waveform is starting angle with certain angle, phase difference. So the angle between these two, it could be like 30 degrees, 50 degrees, 90 degrees. That's called phase angle. Phase angle is different than a phase. Now we'll see how these three phase is generated. Three phase power is generated basically. So if you look at each winding, phase A, phase B, phase C, I'm showing you in this diagram all the winding is lumped at one place, but in reality this phase A is going to be spread all over here. That's my phase A. Okay, and you can clearly see physically the phase angle between each phase is 120 degrees. Okay, physically we are placing them 120 degrees apart. If you have a two phase is the only one which is going to be different, because if you put them 180 degrees apart, they're going to cancel out each other. Okay, we'll end up no voltage or no power output. Okay, so in two phase usually we keep them 90 degrees apart. That's the only difference. This is for two phase. That two phase is also called split phase. In reality, we don't have any two phase generators. So what they do, they will supply a single phase to our home. We'll use a split phase transformer outside our home. That split phase is going to split the single phase into two phase. We don't need to worry here at this point. When it comes to three phase, that 360 divided by 3, 120 degrees apart. If you have 10 phase, then 360 divided by 10, each coil is going to be placed 36 degrees apart. Okay, now if you look at this phase A coil, usually they don't make this phase A coil as a single winding. They take a small windings, okay, and they connect them either in series or parallel based on the voltage or current requirement. Then once you have those series parallel combination of single winding of those three, so that's phase A, you're going to put phase B here, phase C there. Now all those three phases are going to be connected either star or delta. So basically you have three phases, phase A, B and C. Okay, now how we're going to connect these three phases? Either we can connect them in star, this is called star connection, A, B, C. Okay, or delta, in delta it's going to be like this, A, B, C. Now phase A, VAN, is nothing but voltage between A and neutral. So neutral is right there. Here when it comes to delta, we don't have neutral. Usually they show you some dot inside with grounded, but in reality there is no neutral in delta connection. So VAN is between A, phase A and neutral. That's called phase voltage. We'll talk about those things later, but look at the phase angle between all three. Each phase is going to generate the same value because induced EMF equal to, according to Faraday's law, minus N times d phi by dt. N is nothing but number of turns on each coil. So we are keeping each coil with the same number of turns. So, and at the same time, the rate of change of magnetic flux is going to be same in this generator. Okay, so this generate same amount of voltage, but the voltage, there is a physically 120 degrees apart angle. So phase A is going to be start at 0, phase B is going to be minus 120, phase C equal to is going to start at minus 240. Let me show you some animation which I found it online. Here is the animation. I found this animation on online, engineering.stackexchange.com. Okay, here, I mean, he didn't provide the source, saying that its website not found. So if you look at here, that's phase A, phase B, and phase C. Okay, so look at this. When the North Pole reaches A here, when the North Pole is here A, that's the voltage generated in A coil, and when North Pole reaches to B, that's where it's going to start, the red line, that's going to start producing the voltage. I mean, how come we have lines here? Assuming that basically you're taking these waveforms, maybe you started the generator after 1 second or 3 seconds. After some time, this is how the waveforms are going to look like after some time of starting the generator. Okay, that's how all the 3 voltages are going to be generated. So here you see, I mean, pair of windings. I mean, so this is AA, BB, CC. Instead of using single pole, they used double pole. Both of them are same. The previous picture or this animation, they're saying the same thing. Now, what is the advantage of 3-phase compared to all other phases like 4-phase or 5-phase? Why don't we use 4-phase or 5-phase or single phase? Now, when it comes to, I mean, at this point in the entire world, we have only 2 systems. One is single phase system or 3-phase system. Why not 4-phase? Why not 5-phase? I'll talk about it in a minute. But let me compare between single phase and 3-phase. Now, I'm comparing single phase system with 3-phase system. A 3-phase generator will generate 1.5 times of more power than single phase generator of the same size. So if we look at the same size single phase and 3-phase generator, 3-phase generator will generate 1.5 times more power. 3-phase motors are self-starting motors, but not the single phase, because 3-phase power always is a rotating magnetic field. So it gives you rotating magnetic field. Whenever there is a rotating magnetic field, motor automatically starts. When it comes to single phase, it's alternating magnetic field. Since it's an alternating magnetic field, it won't self-start basically. So that's the reasons all the single phase generators, either they use capacitor to start or they use split phase. Okay, another important point, single phase power is pulsating, since voltage and current will reach 0 at least 120 times each. So if you look at a single phase system, okay, here is a voltage with 60 Hz frequency. 60 Hz means we will see 60 number of cycles in 1 second. Okay, so this is 1 cycle. In 1 second, we will see 60 of this. So if you look at this voltage becomes 0 twice in 60 Hz frequency cycle. Okay, so basically voltage is going to be 0 120 times. So those lights are flickering at least 120 times in 1 second in our home or in our classrooms, but our eye cannot catch that flicker. Okay, when it comes to 3-phase is a continuous power supply. So basically if you look at this voltage, look at this value, this never is going to be 0. I mean, that's a minimum 0.5 times the maximum value. Okay, so the voltage is never going to be 0. That's the advantage. Less copper needed for a 3-phase machine of the same size compared to the single phase machine. Transmission line losses are less in 3-phase system, and less amount of copper needed to construct a 3-phase machine. That's the same point, by the way. Now, why don't we go for 4-phase or 5-phase? Basically, in the United States at this point, it will cost us around $300,000. So $300K, $300,000 per mile to construct a 66 kV line. Usually the transmission lines are 33 kV for short distance or 66 kV, and then 132 kV. Sometimes you might see 120 kV. I mean, some places in the United States especially, this is 110 kV lines instead of 132 kV. But when you go to Europe, most probably you will see 132 kV lines. The next one is 230 kV lines, 500 kV lines, and then 750 kV lines, then 1000 kV lines. 1000 kV lines, 750, we don't see much, but 110 kV lines and 230 kV lines are the common ones. Sometimes you see 500 kV lines too. So to build a 66 kV line, it will cost us around $300K per mile. So here it's a 3-phase line, so we are using only three wires. Okay, so since only 3 wires, the tower is carrying only 3 wires. When it goes to the higher value of voltage, 132 kV line, since the voltage is higher, you have to maintain more distance between each of those 3 wires. So the tower, to build this tower, must be more expensive than 300K. Now when it goes to the 4-phase line of same 66 kV line, so 3-phase 66 kV line needs to carry only 3 wires. A 4-phase line needs to carry 4 wires. Okay, so you are paying extra money for the 4th wire, as well as you have to build a tower a little bit bigger because then you have to maintain minimum distance between 2 wires, because all the wires are live wires. Okay, so that will cost more to build a transmission line. So when they compare all these economical point of view, they end up choosing a 3-phase system. So the entire world uses either single-phase system or 3-phase system. Okay, that's about introduction of a 3-phase circuit. In the next example, I will talk about the connections of a 3-phase circuit. Thank you.